So we have basically three different ways we represent chemical equations between ionic compounds. They're molecular equations. Now, they're not really molecules, but it's just the name that we use when we represent everything as compounds. So, a molecular equation example would be potassium hydroxide with magnesium nitrate to make two potassium nitrates and uh, a magnesium hydroxide solid. This would be a molecular equation because everything's shown as its formula. Now, there are two other kind of equations that we use that are very common, and one's called the complete ionic equation. And basically, everything that breaks up into ions, we write it as ions in the complete ionic equation. Now, when you go to write one, um, basically, this is the list of things that you'll break up into its ions. So aqueous strong electrolytes is the general class, but soluble salts, strong acids, and strong bases are written as ions. If it's insoluble or a weak electrolyte or a non-electrolyte, we leave it written in molecular form. Okay, so let's take a look at this one and decide what we're going to break apart. Well, this is an aqueous, right? Ionic compound, so we'll split that into ions. This is aqueous, we'll split that, and this is aqueous, so we can split that one as well. The only one we don't split is the magnesium hydroxide, which is a solid, so we'll leave that one together. Okay, so let's do that. And because this equation is balanced, what we should try to do when we write it is we should try to write it balanced as well. So I'll have two potassiums in that case. So two potassium ions plus two hydroxide ions. And then I'll have a magnesium ion, which is Mg2 plus, and a nitrate ion, which is NO3 minus, like that. And then we want to keep that balanced, and so since there were two of them, I would put a 2 here. So make sure you don't leave the subscript 2, because that's just indicating how many of those are in the formula. It's not actually part of the formula of the polyatomic ion nitrate. Now, for the product side, we'll have 2K plus, like this, and we'll have two NO3s, and then magnesium hydroxide, we'll leave it together unchanged. So I'm going to write MgOH2, and we'll write solid after it like this. Now these are all different reactants over here, and these are products, so you need to have plus signs in between. Now the other thing that you should have written after every single one of these is the term AQ, and all I'm going to do is do this to indicate that it's aqueous. Like that. Now, I'm going to show you another type of equation here. This is the complete ionic equation. But remember, we talked about an equation called the net ionic equation, and that's the equation that basically says who's working from the reactant side and what product did they form. So we're thinking about it like that, and you're looking at this equation, what didn't change, right? So nitrate didn't change. So these go away. And then potassium didn't change, so that goes away like this. And now the order on the left side doesn't matter that the OH is before the magnesium, because that's just the order we wrote them in. It's not that important. But what's left, these two and this, constitute what is known as the net ionic equation. So I'll rewrite it like this, Mg2 plus aqueous plus 2OH minus aqueous makes MgOH2, and that's going to be a solid. So this is my net ionic equation. And then the ions that didn't do anything, for example, the potassium and the nitrate, right, on both sides are exactly the same. These guys are known as spectators, or spectator ions. They didn't actually do anything. They sat in the solution the whole time and watched the magnesium and the hydroxide form the magnesium hydroxide. So here's another example of a complete ionic equation, and what I want you to do is identify the spectator ions and then write the net ionic equation. So I'll go ahead and pause it and give it a shot. Okay, so this is what I came up with. Again, I used a squiggly line so I wouldn't have to write AQ over again. But the nitrate is the same on the left side of the reaction arrow as on the right side of the reaction arrow, and the potassium is the same. And really, only the ions that are in the lead chloride are the ones that are part of the net ionic equation. So I crossed out my spectators, that's how I identified them. And then I wrote lead 2 plus 2 chlorides makes lead chloride, like that, lead 2 chloride. And so that's my net ionic equation. So just sort of to summarize the representations of reactions, it starts with the molecular equation, which is what we get when we predict the products and use the solubility rules. And then again, applying the solubility rules, we write everything that's a soluble ionic compound or a strong acid, we write them as ions. And then the net ionic equation is when we remove the spectator ions from the total ionic equation, and that leaves us the net ionic equation.